So how was your break, everyone? I actually graded the exam long ago, but I didn't want to spoil your break. I was like, well, I'm going to give them the exam when school starts instead of posting the grade on Brightspace. That's why. So since the exam was bad, actually you guys did much better than my afternoon class this time. Usually it's the other way around. My afternoon class, they always did great compared to you guys. But this exam was, I don't know what's wrong with them. It was opposite. You guys did better than them. So almost all of them failed in that class. Here, how many failed? Let's see. 11. 11. Actually, 11 out of 20. More than half. Uh, okay, so I was thinking of giving you a makeup, but then I realized I don't have time to grade them. So I cannot give you a makeup. Instead, I'm going to make the fifth exam cumulative with chapter 10 and 11. So if you didn't do well in this exam, if you do well in the next exam, especially the chapter 10 portion, then I'm going to replace this grade with that grade. Okay, so as long as you do well in the fifth exam, this grade will be replaced with the better one. So if you fail this exam, as long as you have high score in that exam, you're fine. Okay, but it will be cumulative chapter 10 and 11, entire chapter 10 and 11. And our exam was based on up to 11.4, the last exam, but the next exam will be not so 11.4, 10.4. So we still have 10.5, 6, 7, 3 sections from chapter 10 and few sections from chapter 11. And your next exam will be 3 weeks, within 3 weeks, I think. On 9th, May 9th. So today is 22nd. We have this week, next week, and then one more week. So you have 3 weeks time to prepare yourself, study again chapter 10 materials every day. And then by the time you have your exam within 3 weeks, you're ready for chapter 10. And I'm going to ask not any question outside of the exam, okay? So whatever we have in your exam, I'll ask same question with different things, different function, different everything. But as long as you study the exam oil, the last exam, you'll see those questions in the next exam. Not all of them, but those questions where people made most mistakes. Okay, so this exam has 15 questions. Probably I'll take around 7, 8 from this exam, and then the rest will be the rest of the exam. The rest of chapter 10 and 11. Any question? Okay, so before the exam, we started rationalization. We said we don't know how to divide by radical. We know how to add, subtract, and multiply and simplify, but the only thing we don't know is divide. So instead of dividing by radical, we do rationalizing. And when we rationalize, depending on the scenario, we take different steps. For example, when we have only one term on the denominator, we multiply top and bottom by that, whatever makes the power and radical same. For example, in order to get here the square root, we want square power. So all you have to do is multiply top and bottom by the exact same thing on the denominator. So we end up getting the same thing squared time. And that was our goal. Have the radical and the power same so that we can cancel them. And we end up getting only the inside, the radicand. On the numerator, as long as we have the same radical, we can keep our radical and multiply the inside. So if square root 3 square root of 2, that gives us square root of 6. And we don't have to do anything on the numerator because our goal is to get rid of the radical sign from the denominator. So we stop here. We also see an example where we don't have square root, but we have cube root. Now, cube root means we want cube power. So our goal is to, at the end, to have cube root of 7 with a cube power. That means here we are given 1 power. We need how many more to have 3 powers? 2 more. So you multiply top and bottom by 2 of them. Either you can do this way, or you can just write it twice. Cube root of 7 times cube root of 7. So you can see you have 1, 2, 3 terms exactly same. So we have cube power. So cube root, cube power cancel out. On the denominator, we have the single 7 without any radical. On the numerator, we have the same roots, so I can multiply the inside. So we have 7 times cube root of 7 times 7, 49. So 7 times cube root of 49. Cube root of 49 is not simplificable any longer, but we can cancel the 7 on the numerator with the 7 on the denominator. So we end up getting nothing on the denominator and cube root of 49 on the numerator. So depending on whatever radical we have, we want that power on the denominator. So we multiply by 1 less than whatever we want. So we want to have 3 of them, so we multiply by 2 of them. In the last example, we wanted to have the same thing twice, so you multiplied only once. So whatever power you want, you multiply by 1 unit less than that power. Can you guess the 5th one? We want the denominator to have what power? 5 power, because our radical is 5. So how many times you have to multiply the top and bottom? If you do it 5 times, it will end up getting 6 of them. 4 times. You want total 5 power, that means you need to multiply by 4 power. Whatever you want, you multiply by 1 unit less. So multiply 4 times. Either you can do it this way, or you can simply use the 4th power. So 5 radical 2, sorry, 5th root of 2, 5th root of 2, 5th root of 2. We want total 5, so we need extra 4 of them. So we had 2 times to 4, 4 times to 8, 8 times to 30. 8 times 2, 16. So inside the fifth root, we have 32 here. And on the denominator, the fifth root and fifth power, they fight with one another and they will die. So we get the single 2, and on the numerator we have 2 and cube root of 32. And then what happens? The 2 and 2 cancel out. So we get fifth root of 32. So whatever we have, that tells us what we want. If we have 3 cube root, you want 3 power. If you have fourth root, you want 4 power. If you have fifth root, you want fifth power. And depending on whatever power you want, you multiply by 1 unit less than the power. And then you multiply the inside, which is not simplificable. And for the denominator, the root get vanished. It's 16. Man, I said 16, but I wrote 32. What's wrong with me? Thank you. If it was 32, then it is simplificable. Fifth root of 32 is 2. I'm still sleepy. Any question? Can you guess what do you multiply the denominator by here? One of them, right? So square root of 2x, square root of 2x. So we get square root of 2x, whole thing square. And in the numerator, we have square root of 2x with 11. The square root, square power cancel out. So we have 11 square root of 2x and 2x on the bottom. We cannot divide 11 by 2, so we stop here. We cannot go any further. Now, what do we have? One single big root. If you have a single big root, always try to simplify the inside first. Can you divide 7 and 45? No. Since you cannot divide, so step 1, we split our radical. One part goes on the numerator, another part goes on the denominator. We are allowed to do so because of the rule. If you have x over y to the power n, it's x to the n over y to the n. This n could be anything, could be whole number power, could be fraction power. 1/2 means it's a fraction power, so you still can put them on the top and bottom. Now 45. Can you simplify 45? Can you divide 45 by a perfect square number? When you want to divide 45, which two number comes in your mind? And 9 and 5. So see, 9 is a perfect square number. And 5 is not a perfect square number. So 5 and y goes inside one parenthesis, one radical. They are not simplificable. However, 9 is simplificable. So we get 3 from square root of 9. And this is not breakable. So we keep it. That means this expression is same as square root of 7x on the top and 3 square root of 5y on the bottom, because the 45 is breakable. Anytime you can simplify a radical, simplify the radical first and then rationalize. So can you guess what do you multiply by this time? Multiply top and bottom by what? Square root of 5y. So we see the same thing twice in the denominator. Square root of 5y, which is square. So they cancel out. We get 3 times 5y, which gives us 15y. And what do you want the numerator? What do you get? Do they have the same radical? They have the same radical, but they don't have the same radicand. The multiplication has only one rule. As long as you have the same type of root, same type of radical, you're allowed to multiply the inside. Can you multiply 7x and 5y? Yes, we can, because they both have square roots. As long as they have the same root, they can be combined. So it's square root of 7 times 5, which gives us 35, and x times y gives us xy. Can you simplify 35? So we keep our inside. 35 xy under the square root. This is 15y. Let me write it nicely. It looks weird. Any question? Good news, this will not be in the final exam. I'm going to give one of these in the in-class exam, because these are shorter. What will be in the final exam is what we are going to do now. So if you observe all the examples we did so far, they had only one term on the denominator. So you multiply top and bottom by whatever we need, or however many we need of the denominator. But what if our denominator doesn't have one term? It has two terms. When denominator has two terms, we use conjugate. For example, this one, square root of 5 plus 1. It cannot multiply only by the square root of 5, because if you do, then look what happens. If you think you can only multiply by square root of 5, well, yes, this becomes square root of 5 square, but you also have to distribute here. So see, you end up getting square root again. That's why we cannot multiply by one term. We have to multiply by the conjugates. Why conjugate? Because when you multiply to conjugate, you get the difference of perfect squares. So conjugate means exact same two terms, only their middle sign is different. So we have square root of 5 plus 1. Its conjugate square root of 5 minus 1. We have the exact same two things. Square root of 5 and 1. Same two things, the only difference is their sign. If plus is given, you multiply by minus. If minus is given, you multiply by plus. So multiply both top and bottom by that square root of 5 minus 1. So in the denominator, we get difference of perfect squares. Means square root of 5 square minus 1 square. Yes, you can use FOIL to multiply them, but why wasting your time when you know the result? So the square root and square cancel out. We get only 5, and 1 square gives us 1. So we get whole without any radical sign. And we are happy. Now in the numerator, if you have this type of multiplication, like 1 term by 2 terms, don't multiply. If top has 1 term times 2 terms, don't multiply. Why not? Because sometimes whatever we have on the denominator, we can cancel on the numerator. That's why don't multiply. Keep it. Whatever we have, keep it. 5 times square root of 5 minus 1, 5 times square root of 5 minus 1, 5 times square root of 5 minus 1. Here we cannot cancel 5 and 4, but sometimes we get the same number on the top and bottom, or at least they're multiples. So in order to not able to cancel, you keep the single term to see at the end if it's cancelable or not. But if you have 2 terms by 2 terms, you always have to multiply. Let me do one more example before going to the next example. Let's say we have square root of 2 minus 1 divided by, let's say, square root of 3 plus square root of 5. We are rationalizing the denominator. So we want to multiply top and bottom by the conjugate of the denominator. What would be the conjugate of the denominator? Perfect. Radical 3 minus radical 5. So you multiply both top and bottom by that. As a result, the denominator gets simpler. It's the first term square minus the second term square. So what do you get? What is square root of 3 square? The radical and square cancel out, right? So what do you get on the denominator? 3 minus 5, that gives us -2. And we are happy our denominator doesn't have any more radical. But now on the numerator, you have 2 terms. 2 terms by 2 terms, so multiply. And when you multiply, we use FOIL. Square root of 2 times square root of 3. Square root of 2 times negative square root of 5. -1 times square root of 3. -1 times is negative square root of 5. They have the same radical, so you can multiply the inside. Same thing here. They have the same radical, you can multiply the inside. So we have square root of 6 plus and minus gives us a minus. We have square root of 10 minus square root of 3 minus and minus turn into plus square root of 5. And none of them have the same inside. All of the radical on the numerator are different numbers. So you cannot combine them. In order to add and subtract, we have to have the same radical sign with the same radical inside. So we can't do anything, so we just rewrite. Oops, my bad. Square root of 6 minus square root of 10 minus square root of 3 plus square root of 5. So sometimes we can simplify more, we can combine like terms, but sometimes we just stuck with whatever we have. Any question? The next topic is rationalize the numerator. It means we don't want the radical sign on the numerator. Do something so the radical sign from the numerator get vanished. How many terms do you have on the numerator? Numerator. 1 and big square root. 2 terms. So when you have 2 terms and you want to rationalize, what do you use? Conjugate. We did 2 examples already. Since we are rationalizing the numerator, so this time we multiply top and bottom by the conjugate of the numerator. Who can guess the conjugate of the numerator? Any guess? Sergio. This radical is 1 term. The entire radical is 1 term. So you cannot change the sign inside the radical. You only change the sign between the 2 terms. Our first term is 3, second term is the entire radical term. So you cannot change the inside of the radical. You only have to change the sign in front of the radical. Because this is the only thing we have that connects the 2 terms. And conjugate means change the sign that connects the 2 signs. So they connect the 2 terms. So you're only changing the minus sign between the 2 terms with the plus sign. We don't care what do we have inside radical. It's the same always. So 3 plus h plus 4. Don't multiply because we want to cancel h minus 5. When you have this type of scenario, it's always somehow we end up getting something that cancels the denominator. So that's why, to make sure that you're canceling the denominator, don't multiply the denominator. Even though we have 2 terms by 2 terms, still don't multiply. So in the numerator, we have 3 squared minus square root of h plus 4 squared. With the 2 terms, we have 3 and, oh, why did it turn into green? And this whole thing. The first term square minus the second term square. The denominator stays same, h minus 5, 3 plus square root of h plus 4. 3 square gives us 9. And what happens to the second term? The radical and square cancel out. So we get h plus 4 inside the parentheses. Why inside the parentheses? Because we're going to subtract this thing. As a result, it will change the sign. So we get 9 minus h minus 4. We have like terms here. So we have 5 minus h. That means on the top we have 5 minus h, and on the bottom we have h minus 5, 3 plus square root of h plus 4. Can you cancel 5 minus 8 with h minus 5? What do you get? Are they exactly same two things? We have 5 minus 8. So 5 is positive, 8 is negative. But in the denominator, we have 8 minus 5. This time, when 8 is positive, 5 is negative. So if you cancel them, what do you get? Okay, let's say you have 5 minus h divided by 5 minus h. If you cancel 5 minus h by 5 minus h, what do you get? 1. Because we have the exact same two things. But here, we don't have the exact same two things. It's almost same, just their signs are different. So what do you get this time? -1. So we end up getting -1 instead of +1. We get +1 when you have the exactly same two things. But when you have their signs different, we get the same one with the negative sign. So we have -1 on the top and 3 plus square root of h plus 4 on the bottom. And now look what they're saying. Evaluate h for 5. They're telling us, hey, h is 5. Now find out how much you have for this expression. So we have -1, 3 plus 5 plus 4. -1, 3 plus how much? 9. And do we know what is square root of 9? 3. And now what do you have on the denominator? 6. So you cannot stop after rationalizing. We have to replace x with a given number and then simplify further. Well, sometimes this question comes in the final exam. Not always, sometimes. Any question. And you're going to see this type of question in the homework. So do the homework. When we skip the rest, oh, we have only one problem. Never mind. The next question is same thing. It says rationalize the numerator. But before you rationalize, let's simplify. We have 3 power here and 5 power here. So cube root of 2, cube root of x to the 5. Can we split x to the 5 into 2 pieces? One is divisible by 3 and one is not divisible by 3. How many powers of x is divisible by 3? We cannot divide 4 by 3. So how many of them we can divide? 3 of them, right? So you put 3 of them inside 1. And how many left then if you take 3? 2. Now the 3 of them and 3 power, they cancel out because they're the exact same things. And we get only x. And here we have cube root of x squared. And this is not breakable, so it's cube root of 2. But since we have the exact same two things, we are allowed to multiply their inside. So we get x times cube root of 2x squared. So the numerator is x times cube root of 2x squared, and denominator is 9. So anytime you can simplify your radical, try to simplify that fast. In that way, you don't have to cancel anything at the end. So now we rationalize. We have cube root. So we need to multiply by how many more? 2 more. So 2x squared cube root of 2x squared. 2x squared cube root of 2x squared. We want 3 of them. We only want, so we need 2 more. As a result, on the numerator, we have cube root of 2x squared. 3 of them on the top. And on the denominator, we are allowed to multiply the inside because we have the same cube root. So we have cube root of 2 times 2, 4. X squared times x squared is x to the 4. Cube root, cube power cancel out. We have x times 2x squared. 9 times cube root of 4x to the 4. But look, here our power is bigger than the root. That means we can simplify it. So this becomes cube root of 4, cube root of x3, and cube root of x alone. 4 of them we can split into 2 pieces. One is 3 and one is 1. Oliver. No. Cube root, cube power cancel out. We get x alone. But these two, it's not simplificable, so we can put them together. Cube root of 4x. That means we have x times 2x squared on the top, 9 times x times cube root of 4x on the bottom. We can cancel the x with the x. Put this a little bit to the side. Root of 4x. So at the end, we have 2x squared on the top, 9 times cube root of 4x on the bottom. And none of these are cancelable. If this seems too hard, let me show you a shortcut. Cube root of 2. Cube root of 2x to the 5 over 9. Cube root of 2x to the 5 over 9. So, method 2. Our goal is to cancel the cube root, right? We are given cube root of 2x to the 5. Now we definitely need to multiply by something so that at the end, whatever we have inside the cube root, we have the same thing cube times, 3 times. That is our goal, right? Have each element have the same power as the radical. So for 2, we have 1 of them. How many more we need to have 3 of them? 2 more. So 2 squared. Now we only have x to the 5. How many more we need so that we can divide by 3? Definitely 5 is not divisible by 3, right? How many more we need here so that we can divide by 3? 4 more. Can you have anything smaller than 4? With 5, what number you can add that is divisible by 3? What comes after 5? Can you divide 6 by 3? So how many more exactly you need? Just 1. If you have just 1 more power for x, you're done. So we need only 1 more x, only 1. So what happens? We have 1, 2, and 2, 2 here. That combination gives us 3 of them. We have 5 of them here and 1 of them here. That combination gives us 6 of them, right? So cube root of this and cube root of that. So 2 square means 4 and x. So cube root of 2 cube, they cancel out. We get a 2. And this gives us x to the 6 over 3, which is 2. So x squared. And the denominator, we cannot do anything, so we leave it alone. See, this is the exact same answer as this one. But we did it only one step. So if you can think of what is given and how many more you need to get your power same as the radical, just add those things. You don't need anything extra. Well, again, this will not be in the exam, but it will be in the homework. So most of the thing we did today will not be in the exam, but they'll be in the homework and your quiz. What going to be in the exam? I mean, one of them will be in the exam from the rationalization. What will be in the final exam is this. Solve the radical equation. We know how to add, subtract, multiply, divide, simplify. The only thing you need to know is how do you apply all of the things you have to solve the radical equation. When you solve radical equation, you must check your answer always. If you don't, you get 0. Because sometimes we get some solution that actually doesn't work when you substitute them into the equation. So ignore all the details, blah, 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 blah. Let me show you one example. How do you solve radical equation? So to solve radical equation, first thing we must do is get the radical alone. Why? Because when radical has something in the front or something on the right, it's very strong. And we cannot break anything strong, right? You cannot fight a strong person. So what we do, we get rid of all the things that makes the radical strong. We get rid of anything what we have on the right side or on the left side. Anything we have with the radical, get rid of them first. Get your radical alone. When the radical is alone, it becomes very weak. At that time, we apply its power. Whatever radical we have, you apply its power. So you have square root, you apply square power. If you have cube root, you apply cube power. If you have fourth root, you apply fourth power. So whatever is radical, you apply that power on both sides. As a result, the radical and the power cancel out. There is no more radical. However, on the right side, if you have just a single thing, it's easy. But if you have two terms, you have to use FOIL to expand that. So here we have the radical minus 1 equals 8. First thing is we get here the 1. So we add 1 to both sides, 8 becomes 9. Now square root is alone, so we apply the square power on both sides. So there is no more square root. We have only the radicand, and the other side is 9 squared 81. And then it's basic algebra, we get the x alone. So we get our answer is x equals 42, but you cannot stop. As long as your radical is an even radical, you always have to check your answer. If it's odd radical, you don't have to. Because odd radical is fine, it doesn't give us any problem. But the even radical is bad. So we substitute that number into the original equation and see if the both sides are same. If the both sides are not same, we cannot accept that answer. Okay? So that's the rule. Get your radical alone, do whatever you need to do. Once it's alone, apply its power, and then simplify. Only 3 things. Sorry. And then once you simplify, you check 4 things. So let's do some examples. Is our square root term alone in one side? No. So what can you do to make it alone? What is our first step? Which one we get rid of? The negative sign or the 8? 8. So we have plus 8. How can you get rid of plus 8? Minus 8. So we get negative square root of 20x equals negative 10. Is our square root alone yet? No. We have a negative. So multiply or divide both sides by negative. So we get square root of 20x is 10. Is our radical alone now? Yes, finally it's alone. That means it's time to apply the power and make it vanished. So square root, square power cancel out. We get only the radicand, which is 20x. And what do you have on the other side? 100. To solve for x, what do you do? Divide by 20. Now we can cancel 1 0 of 100 and 1 0 with the 10. So 0 0 cancel out. 2 goes to 10 how many times? 5. Even though you have the answer, but he cannot stop. We must check. We have negative square root of 20x plus 8 equals negative 2. So this x is 5. So negative square root of 20 times 5 plus 8. We want to see if the left side gives us negative 2. So 5 times 20 gives us 100 plus 8. Square root of 100 is what? 10. So negative 10 plus 8. And what is negative 10 plus 8? Negative 2. Which is exactly the same thing what you wanted to get. So, yes, 5 is a real answer. It's not scam. It's real thing. This is too easy. It will not be in the exam. What will be in the exam is the next one. And also in the final exam. What is our first step? No, you're not rationalizing, you're solving. You need to get your radical alone. So this x is a bother, so you add x to both sides. Remember, your goal for solving is always get the radical alone, because when it's alone, it's weak. So we get 2x minus 1 under the radical and x minus 2 on the other side. It's negative 2 plus the x, which is same as x minus 2. Is our radical alone now? Yes, it is. That means we can apply the power on both sides. So the radical and power cancel out. We get radicand. But on this side, we have to do FOIL. Power means you have the same thing twice. So it's not x squared minus 4. It's x minus 2 times x minus 2. So it's x squared minus 2x minus 2x and then plus 4. So 2x minus 1. We have like terms, minus 2x minus 2x. So what do we have? Negative 2x minus 2x gives us negative 4x and then plus 4. So see, if you distribute the power, you get only x squared and 4, which is wrong because it should be x squared minus 4x and then 4. And now see, we have the highest degree 2. Anytime we have highest degree more than 1, try to bring everything to one side. So we don't want the 2x on the left, so we subtract 2x. We don't want the 1 on the left, so we add the 1. Because solving means we have to see 0 in one side. So we keep our x squared positive and bring the left side to the right side. So you have 0, x squared, and then what? Minus 4x minus 2x. Minus 6x. And then 5. Now it becomes a simple quadratic equation. Is it factorable? Can you think of two numbers multiplied to 5 combined to 6? Multiply to 5. That means you are looking for the factor of 5. What factors do we have for 5? 5 and 1. Now what sign we want in front of 5? Negative, because our middle sign is negative. Now if 5 is negative and you want to get 6, what sign 1 has to have? Plus 1 or minus 1? Minus. So it is factorable. Negative 5 times negative 1 is positive 5. Negative 5 minus 1 is negative 6. Both work. So we get x minus 5 equals 0. X minus 1 equals 0. So we get x equals 5 and x equals 1. But we cannot stop, because we need to check both of them. Are they real or they're scam? So we substitute them. 2x minus 1 under the square root minus x. We want the result to be negative 2, just like the previous one. So you have to check it twice. 2x minus 1 minus x. We want the results to be negative 2. Here our x is 5. So every x you see, replace them with 5. Here our x is 1. So every x you see, replace with 1. So it's 2 times 5 minus 1 minus 5. And this is 2 times 1 minus 1 under the radical minus 1. Now 2 times 5, what is 2 times 5? 10 minus 1, 9, right? And what is square root of 9? And what is c minus 5? Positive 2 or negative 2, which one? Negative 2, because 5 is bigger. So see, we have the same thing. So we are going to accept this as our answer. Now we have to check if 1 also works or not. So 2 times 2 is 4. Sorry, 2 times 1, my bad. 2 times 1 is 2. 2 minus 1 minus 1. 2 minus 1 is 1 minus 1. Square root of 1 is 1. And what is 1 minus 1? 0. But what do we want it to get? Negative 2. Are they same? Not same. So can we accept x equals 1 as our solution? No. X minus 1 doesn't work. The only solution we have is x equals 5. That's why we always have to check, because sometimes one doesn't work, sometimes both don't work. When none of them work, we say there is no solution. When one of them works, we said, well, whatever works, that is our solution. And sometimes both of them work. So you have to check. We don't know what is what. Question? So in our next class, we are going to do a few more of these. We are going to try a few of these, and then we are going to do complex number. And we are going to do everything again: add, subtract, multiply, divide, simplify, all of these with complex number. And then once you're done with 10, we are going to do 11, which is parabola, all about parabola. Any question? I did not, but I'm going to mark now. You can leave, no problem. I always remember who is here and who isn't. So today is for 22. I didn't see Eliza, Fabricio, Sergio was here, Miley was here, Oliver here, Himadri here. 1 minute, Jane. Mustafa here, Jacqueline here, Jane here, Anaya here. I didn't see Atsiri, Stitlali, Mohammed, your exam. Saida here. Bye. Mohammed here. No Renaldo, no Jeniel, no Jeremiah. Pamela here. Filia here. No makeup exam, but the next exam is cumulative.